Good day, everyone. I hope you are all doing well. It's a pleasure to be here today to participate in this webinar and to talk about statistics and introduce it to all of you. It's something that I'm very passionate about. Just so you know, I'm calling in from Boston, so it is noon time for me here. So for those who are on East Coast time, good afternoon. And for those who are on West Coast time or earlier, good morning, I should say. So just a little bit about me. So I am the Assistant Director of Statistics and Analytics at the Tufts Center for the Study of Drug Development. The type of work that we do at the Tufts Center focuses on actual clinical development in addition to policy types of questions and economics-related questions involved in drug development. Some of you may know my colleagues Ken Getz, he's very, very heavily involved in clinical operations, as well as Joe DeMasi, who calculates every couple of years the cost to bring one drug to market. So I'm the Assistant Director of Statistics and Analytics here, and I also have a secondary appointment as instructor at the Tufts University School of Medicine, where I teach med students, actually, similar topics such as what we'll be going through today. And so just a little bit more about me. I have 10 years of experience in drug development and 4 years experience in consulting. So just to share some of my references with you, the slides that you'll be looking at today, they were not all created with my vision. I have to give credit to where credit's due to my old professors, Misha Eliasho, Jerry Dalal, and Olaf Daman. He's our epidemiologist at the Tufts University School of Medicine. And then I also have to thank Shashi Satyanarayan, whose examples we will be using for today. Okay, so then just to talk about our agenda for today, so we're going to start first by focusing on descriptive statistics. So firstly, recognizing them, and then how to interpret descriptive statistics when you see them. And then we'll talk about how to summarize continuous data with appropriate descriptive statistics. So that will be, I'd say, the first half hour to 40 minutes of our session. And then we'll move into interpreting confidence intervals and explain how they are calculated, and that will take a good I'd say half hour to go through. We're going to break it down bit by bit so that we understand the concept behind confidence intervals. From there, we'll segue into how to interpret a p-value, and we'll explain the concepts behind hypothesis testing, but using one specific test called Student's t-test as the example. We won't be going into too much detail today about some of the other tests that biostatisticians use. I have them listed on a screen, and I'll show you examples of them. But at the end of the day, interpreting a p-value is consistent across all of those tests. So what's essential is understanding that, and less essential is understanding the actual tests that the statisticians have selected for the data. And then we'll close by talking about, or sharing some statistical terms that are used in clinical research so that we're all aware of their definitions and how to use them when communicating with your biostatisticians, and then also identify approaches to be comfortable communicating with them. And we'll talk as a group, as a collective, to see where some of the concerns are with speaking with statisticians, and then just some checklists for all of you in case there are, in order to address some of those concerns. So we're going to start very basic. So the first question is, well, what is statistics exactly? And so why are we all here today? What is this about? Why is medicine and drug development essentially all about statistics? And the idea is, or the definition of statistics is, the process of understanding how to accurately summarize data and minimize the occurrence of a chance finding. And it's that minimizing occurrence of a chance finding that's the most essential, specifically when we talk about something called inferential statistics, which I will address in a moment. So put another way, what statistics does is it takes the data that NIC CDC has been capturing, for example. It takes the data, summarizes it so that non-statisticians can understand it, and so that for medicine, specifically for drug development, we know that A, the drug is efficacious, it's doing what it needs to do. We can also put together our labels so that we understand what proportion of subjects or individuals who are using this drug, what are the types of adverse events, for example, that they might expect, and what percentage of the population were impacted by those. So some other examples also include, when comparing two groups in a trial, are the two groups being compared? Are they themselves the starting groups? Are they the same or are they different? That's one thing also that statistics tells us. And then also when looking at diagnostic tests, if there's a new diagnostic test on the market, is it more precise than the older test? Can it be the new gold standard? That sort of thing. So all of this is why we have statistics and what statistics hopes to answer. So to talk about, there are two types of statistics, one of which we will spend, as I mentioned, a good hour of the day discussing, and that is descriptive statistics. And what that is that it's any type of analysis that describes the data that we're looking at. And it's just, there's no hypotheses attached to it, no conclusions made from the analysis. It's just quite literally describing it. We see a lot of this with the census, for example. I think it's 10 years, I believe. Every 10 years or so that we fill out these types of forms, and then we hand them off back to the government, and then the government just describes who's in the U.S., who is, within specific addresses, who lives there, that sort of thing. And so the types of ways that we describe those types of statistics tend to include trying to understand what we refer to as central tendency, and then also the spread around the data. That's what descriptive statistics typically tells us. And then we have a different set of statistics that are referred to as inferential statistics, and that's an analysis that relies on a sample to estimate a population. And so that's, for example, a clinical trial. So with a clinical trial or with any type of analyses that are inferential in nature, a hypothesis is generated and then it's tested through a clinical trial, for example. And so then from there, the types of data that we're interested in analyzing include what is the central tendency, what is the spread of the central tendency, and then what's the spread of the actual data set. And taking all that from the sample data that we have and trying to infer it up to the population level. And so the idea behind inferential statistics is that we're trying to determine what are called parameters. So the parameters are what describe the population as a whole, and we're determining these parameters from estimates, and those estimates come from our sample data.